Thank you again for joining us today, and thanks for the audience. So today will be the third talk in our series of talk on human-centric design of the indoor built environment. And as you can see, the main idea of this series of talks is to have like this connection and this knowledge exchange with recent research outcomes and also industrial innovation. So we had Velux in our first talk, and then we had Michael Kent in our second talk talking about view. And today we will be joined by Professor Sergio Altamont and Dr. Laura and Dr. Marshall from University Catholic de Louvain to share the recent research outcome. So thank you and welcome.
Thank you. Thank you for the invitation. And
thank
hello,
you.
everybody.
So, yeah. Now, I think we may start. I would just quickly introduce myself and you guys as well. So I am Sahar Abdulwahab, lecturer in the built environment at Leicester School of Art, Design and Architecture in Leicester, UK. And my guest today, so first of all, we will have Professor Sergio Altamont. He is a professor of architectural physics. Professor Sergio develops his research activities in the context of the group Architecture Climat, and his research expertise lies in the intersection between architectural design, indoor environmental quality, human psychophysics, and sustainable development, aiming at the development of testing of strategies and solutions that enhance user comfort, health and well-being, support energy performance, and improve the spatial qualities of building design. And then we will have Laura Marais. So Laura is a postdoctoral researcher from UC Louvain as well, and she's an architect and a researcher dedicated to the sustainable development of the built environment. And she has an emphasis, her research focuses on human factor, environmental factor, and passive design. She has experience in BIM. And she's interested in new technologies and tools that result in efficient and comfortable built environment. So welcome, Laura. And last but not least, we will have Marshall Kazin, and he's working at University Catholic de Louvain. He's a postdoctoral researcher as well. So Dr. Marshall holds an integrated master PhD degree in energy science and engineering. He has research interest in building lighting or daylighting, visual comfort and overall building performance evaluation through measurements and simulation tools. So welcome all again. And
Thank
now
you.
the presentation is shared, so the floor is yours whenever you want to start. So the plan is to have like around 45 minutes, more or less, for the presentation. And then we will have a QA session after to receive the questions from the audience. So here you go.
Thank you. Perfect. Thank you, Sahar, for the invitation, and thank you to everybody for attending, whether you are attending live or recording. Do you see the screen? Do you see me? So everything is fine. Do you hear us? Everything is correct. We can start with the presentation. Okay.
Yes.
Good. So as I said, thank you, Laura. Thank you, Sahar, for the presentation. I have to say, first of all, that I'm very honored to be here because, well, of course, Sahar has been one of my PhD and has done a postdoctoral period here at UC Louvain. And this presentation is actually also a very interesting combination of experience from all of the postdocs that I've had the pleasure and the honor to work with over the last few years. So Laura Marin Restrepo, Marshall Mascareni, and also Seda Cassel, who has actually finished her Marie Curie fellowship here a few months ago, but that also highly contributed to the presentation of today. So today, and the lecture series, from what we understand, is on human-centric design. And actually, human-centric design is also at the core of our interest. The presentation of today is titled, "What is Next?" a new model for comfort, satisfaction, health, and well-being in buildings, which is essentially, we can say, the compendium of a number of different researches that are currently going on here at Louvain-la-Neuve. And why are we dealing with this research? Well, all of us, all of you are working in the field of the built environment. For many years, we've been dealing with the pressing issues of energy demand, sustainability, how to guarantee a sustainable built environment that obviously is working in cooperation with the environment. But from this perspective, we can say that we now have at the moment a number of models which are pretty much defined, pretty much deterministic in the way in which they work. But on the other hand, whenever we put the human factor in the equation, whenever we start looking at the way in which humans perceive and behave in the built environment, all of the confines of the building that we can see in the half bottom of the picture start to become much more blurry. Hence why this picture in the top hand presents a built environment whose confines starts to merge with the environment. And this is essentially what we're trying to do here. We're trying to understand how much humans interact with their environment, internal and external, and how much those interactions may effectively have an influence on the way in which people perceive and behave in the environment. Just to give you an understanding of the level of questioning that we have been putting together over recent years, we have here what most of you would be familiar with. It's just a luminance map of a person sitting at the office in front of a screen. In this case, this luminance map is looking for potential causes of glare. So if you look, for example, at the half bottom of the picture, you should be able to see, if I can laser point it, at this point, you can see that the person has a contrast ratio of about 1 to 10. Luminance of the screen is 206, luminance outside is 2461. So based on our current models and understanding of glare, the person is supposed to be in a condition of high contrast, hence the blind is drawn. So our deterministic model at the moment says that, okay, this is fine, this is how it works. The person is at risk of glare, therefore the blind is drawn down. However, the same person under a different condition, you can see here, has the same visual task, but in this case, he has a contrast ratio of 132 on the visual task and 7,430 on the background, so about 1 to 20. In this case, the person has not drawn down the blind. So this would contradict all of our models of glare and understanding of potential risks of disability or discomfort. Why is this happening? What is the interaction that is currently at place between the person and the environment that, in a way, is starting to dispute the correctness of our models? So this is a bit of the premise that I want to give to this talk. And later on, I will maybe reveal you what is happening here and why we think that this phenomenon takes place. First of all, as I said before, I mean, most of us, and I'm sure most of the people that are attending the lecture today, for years have been discussing about the energies versus human nexus. So energy consumption in buildings and how people can actually achieve comfort in buildings while still keeping an eye on their energy consumptions. We're not obviously stating the obvious here. We know that buildings use 40% of the energy of the whole energy package. This is an information that comes from the US DOE on 2011, but is of it could be actually data that is more recent because the percentages are still found to this very day almost everywhere in the world. The question that we should actually ask ourselves, are buildings actually using energy, or is energy used by people in order to achieve and retrieve or maintain their condition of comfort, satisfaction, health, and well-being? Well, actually has a publication from Yanda of 2011, the same year of this infographic, says buildings don't use energy, people do. So the question that we should ask is why people use that energy and how those 4 different levels of human experience, comfort, satisfaction, health, and well-being, can effectively be maintained. So in the field of our research, we often talk about indoor environmental qualities. And indoor environmental qualities, based on the US Institute of Occupant Health and Safety, is the quality of a building's environment in relation to the health and well-being of those who occupy the space within it. Essentially, if we look at the general building layout, the acoustic quality, the air quality, the maintenance, thermal comfort, lighting, and so forth, we should be able to control the conditions that are present inside the building in order to guarantee what? The comfort, satisfaction, health, and well-being of people. And for this, we have a number of standards that are resulting from a number of different research endeavors from everywhere in the world. But is it actually happening? If we keep indoor environmental qualities responding to the requirements of the standard, can we guarantee the health and the well-being of people inside spaces? Actually, recent research, and I'm here referring to the indoor generation research by Velux, tells a bit of the contrary. If we look at what staying indoors actually implies today, we have significant evidence that tell us that staying indoors is not at all actually healthy. And this is due to a number of reasons, but also is due to the fact that people differ in needs, preference, behaviors, scenarios, and situations, while actually standards tend to be somehow regulated based on mean distributions. But actually, if we really want to look after the perception and the experience of people, we should acknowledge those differences in needs, preference, scenarios, and situations, and also accept the fact that patterns of stressors and profiles of occupants interact at and between levels in a dynamic way. Most often in research, we refer to buildings in a rather static way. We look at the buildings and we look at the number of factors that intervene within the building. But is there anything static about buildings? If we look, for example, of fluctuations in air temperature, or if we look at differences in surface temperature that, for example, could come due to sudden presence of sun irradiation on a window, or if we look at phenomenon of air infiltration due to differences in pressures or to wind presence, or if we look, for example, at the phenomenon of discomfort glare, to which I was referring to at the beginning of this presentation, we can definitely check, we can definitely see that there is nothing static about buildings. But on the other hand, there is nothing static about humans. If we look at the equilibrium of human hormonal production of alertness and body temperature throughout the human body across a cycle of 2 days, we can see that many fluctuations characterize the endocrine production of our body. And this is one of the challenges that we have when we start talking about comfort, satisfaction, health, and well-being, since these are multidimensional, psychophysical, and physiological constructs. In order to resolve the need to address comfort, satisfaction, health, and well-being, we have to disentangle the complex relationship between different human systems, but also accept the fact that we still have incomplete characterization of the stochastic processes that drive response to environmental stimuli. So this is a bit of the questioning that we have been asking ourselves for, well, I would say the last 10 years. And I've had the chance of working with a number of scholars of international level in this first publication that we did in 2020. This was done just before the outburst of the first COVID-19 pandemic, where we start questioning about what is well-being in the built environment. From all this work, a number of hypotheses were formulated. First of all, the hypothesis that we try to resolve and address in our research is the hypothesis that there could be significant differences at the temporal and spatial scale between the design and operation strategies for energy conservation, so the energy issue in buildings, the conditions that are needed to perform activities in a state of comfort, what contributes to satisfaction with the indoor environment, what occupants need to be healthy, and the settings that are conducive to a feeling of feeling well over time. Essentially, this hypothesis means that the strategies that we utilize at building and room level in order to save energy may sometimes be in contradiction with the strategies that we would put in place in order to achieve comfort, in order to guarantee satisfaction with the environment, in order to look after the health of people, and in order to make them feel well. On the other hand, another hypothesis that we put forward in our research is that various environmental stimuli may interact or compete at different spatiotemporal resolutions to affect perception and outcomes of comfort, satisfaction, health, and well-being, driving user responses and environmental behaviors. In our research, we tend to be somehow secluded in silos. In a way, we have specialties in thermal environment, we have specialists in lighting, specialists in acoustics, but it's not that often that we look at the synergistic or antagonistic combination of those stimuli. Well, actually, if we look at the way in which we experience buildings, multiple sensory modalities that encode the properties of an environment are not processed independently, but actually they interact with each other. We may not perceive the thermal environment at the same time of the visual environment, since our brain may actually dissect those experiences, but the sensation comes at the same time. So the sensation, which is a relatively straightforward activity of the sensory system, is interacting with each other. Is then our brain that perceive in a process that involves the person, the mind, and experience, and then moves on to the following step of cognition in order to enhance decision and judgment. So this is also a process that we need to look particularly carefully from a neural level in the way in which our behavior is driven by the interpretation that we give to multisensory modalities to whom we are exposed. And in this, we reiterate what we said before. People are all different, and people are different from each other, in this case, intra-individual differences, but are also different from themselves. I may have a different perception with respect to the same sensation at different times of the day, or in different seasons, or in different conditions. So there comes the understanding that in an office building, particularly if it is like for in this case, an open space or a shared space, people will always and ineluctably have different opinions in terms of their perception of the environment. We said we're looking at comfort, satisfaction, health, and well-being, and I'm sure that everybody, if asked, could give a very clear definition of what they conceive as comfort, satisfaction, health, and well-being, and very often referring to standards. But if we look at the definition given by standards, even in this case, we can find some a bit weird contradictions. So, for example, if we ask what is comfort and what is satisfaction, and what is the difference between comfort and satisfaction? The most famous is the ANSI ASHRAE Standard 55 definition of thermal comfort, which is a condition of mind. So again, perception in this case, which means that is a sensation that has been mediated by a neural process that expresses satisfaction. So comfort express satisfaction. So which means that in this definition, comfort and satisfaction should be somehow linked with the thermal environment and is assessed by subjective evaluation. Evaluation is a judgment. So in this case, it implies cognition, which may be relevant to satisfaction, but I'm not sure whether it may be relevant to comfort. Maybe this is a question mark that we need to ask ourselves. Definition was given in the CIBSE Knowledge Series 2006, where they say that comfort is where there is broad satisfaction. So again, comfort and satisfaction with the environment. So people are neither too hot nor too cold. Another way to regard this is the absence of discomfort. I've always been a bit uncomfortable, may I say, with this definition, because I don't think that comfort can be defined as the absence of discomfort. But I mean, we're not here to discuss about this definition. Let's look, for example, at satisfaction as it is defined in the Oxford Dictionary, which says that satisfaction implies a state of mind, again, state of mind, meaning that is a sensation mediated by the brain, which is driven by gratification from a need or desire. A need or desire actually implies that there is a preconcept, so there is something that we have processed before being exposed to a sensation, because we express a need or desire, and it affects or motivates behavior happening in the future, so after the sensation has taken place. So the temporal boundaries of satisfaction and comfort may not be exactly the same. Let's look, for example, at health and well-being. The most famous definition is the World Health Organization. Health is a state of complete physical, mental, and social well-being. Okay, so health and well-being, are these the same or not? Not merely the absence of disease or infirmity. I've been looking also at the scientific literature. There's a definition given by Kuhn-Stevens. The well-being of people is commonly defined in terms of their health, comfort, and happiness. So well-being may be something that goes beyond simply health. And again, Kuhn-Stevens and Manchanda in 2010 in their paper also said that these parameters, health, comfort, and happiness, are evidently interrelated. And one could define health, comfort, and satisfaction as lying on a well-being spectrum from the directly measurable to the unmeasurable. So here comes also another question. If comfort, satisfaction, health, and well-being are slightly different in their construct and connotation, how can we measure them? And even more importantly, can we actually measure them? These are the questions that we asked ourselves when starting to elaborate a model, a conceptual model that could somehow try to disentangle the intricate connotations of these four constructs. A paper was published recently in Building an Environment that I co-authored with Seta Cassel that I mentioned at the beginning of this presentation, Paulina Vegester Martinez and Dusan Lissina from the PFL, and it's called actually as the title of this presentation, What is Next? A New Conceptual Model for Comfort, Satisfaction, Well-being in Buildings. So let's try to recap what we said so far, and let's try to see if we can find a definition of the four constructs of comfort, satisfaction, health, and well-being that can actually be conducive to research, practice, and policies in the built environment. Let's start with comfort. We look at this mug. Immediately, all of us put ourselves in a wintry kind of situation. We're reading a book, it's cold, and the tea or coffee that is in the mug gives us a sense of comfort. But already we're putting ourselves in a specific moment in time, and we are feeling something that changes the way in which we perceive the environment around us. So we can say that the transient and subjective evaluation of the monotonically resolved perception deriving from the multisensory integration of concurrent environmental exposure be defined as comfort. So let's go back. Transient, we move from a state of cold to a state of warmth. Subjective, because it's referred to the way in which I feel. Monotonically resolved perception. At the moment, the only thing I'm thinking is my thermal perception. There's nothing to do with visual. There's nothing to do with auditory. I'm focusing on my thermal environment. Although the thermal environment derives from the multisensory integration of concurrent environmental exposure. Of course, in this moment, I'm reconciling all of the concurrent sensation that the environment is sending me. But this is context and subject related. It can only happen right here and right now. It can only be related to a temporary state. It only exists in this precise moment. So comfort is a temporary and transient perception that can only be related to a temporary state right here and right now. Let's move to a different situation. We have to respond to a survey that asks, how was your day today, thermally, visually, acoustically? In order to respond to that, we have to go back in our mind to all of the states of comfort, all of the perceptions that we have had throughout the day. But in doing so, we are processing by our mind and by judgment all of the perceptions deriving from the sensations that we had, for example. This is satisfaction. Satisfaction implies an active cognitive judgment. I have to stop and think. Comfort is transient, while satisfaction implies a cognitive judgment. Enjoyment that indicates how much the environment meets the expectations and needs. I had expectations before, have then been met or not. Satisfaction is also a projection to forthcoming events. My day was good, but I'm also anticipating what I'm doing next. Has my day prepared me to the next stage? And how can I behave in terms of what I'm doing after this? So it's based on anticipation and opportunities, and is a judgment that is mediated by experience and projected to a future situation. Let's look at this, X-rays. So in this case, obviously, we have a picture, a snapshot on the state of health of a person, but it's a general condition of the body and the mind that is beyond the simple absence of disease. So it's something that may go back to the history of exposures. Entails optimal functioning of the body, so it's not only a physical state, but also peace of mind, confidence, and social connection. It's dynamic and it's temporary. The X-ray is taken now, so obviously it may change in the future, but still it looks like something that takes into account all of my history of previous exposure. It is to be evaluated in a transient moment in time and space, right here and right now, but the breadth of experience that influence my state of health is obviously much broader than what characterizes comfort. And the final construct is well-being, and this is represented by the picture of a person that is climbing through the woods towards the light, the famous light at the end of the tunnel. Well-being is a cognitive process. I'm going through the light. I know what I'm doing. I have actually elaborated all of the feelings, the perceptions that have actually come from my sensory experience. But this is something that is projected over the long term. It implies health and comfort, as Stevens had said in the definition, but also is projected towards quality of life. It's multidimensional. It is physical, functional, social, and mental, but also it entails a combination of flourishing and thriving. It entails moods and it entails emotion. Well-being is something that encompasses satisfaction with life, happiness and pleasant effects, but something that is sustained over. So even if comfort, satisfaction, health, and well-being are very often used almost interchangeably in research and practice, they imply different constructs. And we have tried to put them together in a graphical format with this model that we called NEXT. So why NEXT, first of all? Well, if we look at the number of dimensions, we can call this N. If we look at the experience and expectations of people, we could call them X. And if we look at dimension of time, we could call it T. So the combination of N, EX, and T give us the next model. Comfort is at the very beginning of the scale. So it's something, as we said, that is very often monotonically resolved. So it's one single dimension and is referred to right here and right now. So it only measures something that is temporary. Satisfaction, on the other hand, implies expectations and projections towards the future. It's very often monotonically resolved, so for example, thermal satisfaction, but has a much wider temporal dimension and a much wider impact of experience and expectations. Health, on the other hand, implies more dimensions than comfort, but its temporal constructs are much longer. There's a much longer past of experience that influence my state of health. On the other hand, well-being sits at the top of our model, since in there, the number of dimensions, the experience and expectations, but also the temporal boundaries are much more expanded. So this is the model that we put forward, and we anticipate that that could have significant impacts in terms of building measurements. So, for example, difference in study protocols, you would measure comfort with right here, right now surveys, while rather satisfaction with a transversal or longitudinal survey. We have to give attention to temporal boundaries. What are we asking of people? And of course, we may need to include sensors and tools to measure the different states that can be referred to the different constructs. There's also a difference that this model may have in benchmarking. So building strategies need to be less prescriptive and allow for adaptability, depending on whether we want to prioritize comfort, satisfaction, health, and well-being, but also we have to address the diversity of building users and types and functions of buildings. We have to encompass different spatio-temporal resolutions, and we have to allow dynamic fluctuations in the way in which we contextualize the experience of buildings. Also, design criteria may need to radically change. I'm stating this with a lot of caution, but comfort may not be a prerequisite of satisfaction and health. Actually, in some cases, a slight deviance from comfort, so a slight discomfort, may be more beneficial to satisfaction and health that's staying within the boundaries that are set by standards. A temporary drift from the comfort zone, as it has been said already several times in the scientific literature, may actually be satisfactory and may be healthy. We may actually induce a stimulus to our body that may be healthy for our endocrinal production, for example. On the other hand, if we focus on dynamic and variable human outcomes, so if we let our buildings drift outside of narrow zones of control, we may also induce very significant energy savings. So I would stop here. So I just wanted to give a very general overview of the way in which we deal with the construct of comfort, satisfaction, health, and well-being. And I would like to leave the floor to Laura, first of all, who will get a little bit deeper in terms of this aspect of drifting away from boundaries of comfort in order to stimulate the body. And then to Marshall, we'll actually look at the aspect of how design criteria in building and design methods for buildings can encompass those different levels of comfort, satisfaction, health, and well-being, and energy at the same time. Incidentally, Laura will focus on the thermal environment and Marshall more on the lighting environment. So if, Sar, this is okay with you, I would leave the floor to Laura and to Marshall. I will project from my computer. So just
okay, that's enough. Okay. Thank you, Sergio.
Pleasure. So I'm now back there, and Laura, I will re-share screen, so it's all shared. Do you see the presentation of Laura?
Yes, I can see it.
Okay. So you want to move here, Laura? Yes, please. And I will also put you. So it's already on laser pointer mode in case you need. Okay. There you go.
All right. Can you hear me well?
Yes, we can hear you, Laura.
Okay. So thank you and good afternoon, everyone. Today I'd like to build directly on the conceptual model that Sergio just introduced concerning comfort, satisfaction, health, and well-being in buildings. And I would like to start with a question. Have you ever found yourself tolerating being too hot or too cold because you were sharing a space with others? Just think about that for a second. Because this common scenario highlights this gap that Sergio just mentioned between the average conditions set by environmental standards and the actual varied response individuals have in the shared spaces. Interestingly, this discrepancy could lead to an expansion of the conditions we are exposed to, and not necessarily for the worst. It may seem counterintuitive, but moving beyond our comfort preferences is not always negative. In fact, adapting to a wider range of indoor environmental conditions could lead to significant benefits for users and building energy management, as Sergio just mentioned. So my research delves into in this adaptation process, how we endure, adapt, and ultimately take action to address uncomfortable conditions. And more than that, examines the implication of these adaptations, considering how an expanded range of indoor environmental conditions could actually benefit us. So this research is part of my ongoing postdoctoral project, investigating the relationship between human comfort, environmental conditions, and social dynamics to kind of redefine these traditional indoor environmental standards with an occupant-centric approach. So today I will share this kind of also conceptual framework about tolerance and how individuals perceive, and respond, and how we are developing this research. And by examining these aspects, we aim to offer some insights that challenge and extend this traditional way that we saw the standards. So let's first explore a bit the concept of tolerance, which refers to the extent to which individuals can endure these uncomfortable conditions before feeling compelled to take an action. And this tolerance is not just about the physical sensation of discomfort, but also involves psychological and social dimensions that affect our behavior in shared spaces. Imagine that you are alone in a room where the temperature is steadily rising, increasing your level of discomfort. You might decide to open a window to alleviate this discomfort, thereby directly modifying your environment to regain that comfort. But however, these dynamics change significantly when we share the space with others. Here, social norms, work expectation, or even personal reluctance might prevent the immediate action, leading to a delayed response. And this delay creates a gap between the desire to act and the actual action, exposing you to temperatures that you find uncomfortable and would not choose if you were alone. So the decision to endure these conditions rather than change them marks the beginning of tolerance. But how much can you withstand? We hypothesize that there's a limit to this endurance, and eventually discomfort becomes unbearable, prompting unnecessary environmental action. And this is what leads us to define what we call the tolerance zone, marked by two critical boundaries. The inner one, that will be the threshold which discomfort becomes noticeable and the initial desire for change merge. But due to various factors, such as social norms, as we mentioned before, and others, the actions may not be taken. And the outer boundary, that represents the limit of tolerance, of endurance, beyond which the individual feels an urgent need, let's say, to alter their environment to restore comfort. And this boundary is crucial as it marks the transition from enduring to acting. The intensity and duration of the discomfort, your physical state, your psychological makeup, and the prevailing social context can all influence this tolerance threshold. How annoying the conditions feels to you, what activities you need to perform, how long you have been enduring it, your mood, the presence of others. There's a lot of things that can kind of shape the tolerance. Understanding these boundaries is crucial to highlight the dynamic nature of human interaction with their environment and how the individual perception is connected with a collective behavior. They challenge the static assumptions of these traditional environmental standards and suggest a more fluid, adaptable approach to building design of management. So this exploration forms the core of my project, which seeks to understand the boundaries of tolerance to discomfort in office environment, and of course how these are influenced by these social dynamics, personal preference, and physical setting. And to investigate these tolerance boundaries, we are employing a mixed methods approach. Initially, we perform a fieldwork to identify these boundaries. Then, in a controlled test room, we experimented to see how these boundaries can be measured and extended. And finally, we're in the process to validate and transfer this finding to real shared office environments to enhance user comfort and building efficiency. So I'll just quickly show you some details about these methods. In the initial stage, we monitored 9 shared office spaces at UCLUBAN, involving 45 participants in total. Over the course of several months, we gathered both objective and subjective data to gain a comprehensive understanding of the daily interactions with the office environment. So we recorded all the indoor and outdoor environmental conditions, monitored the time when the occupants interact with the windows, with the blinds, with all the control elements, and complement this information with some questionnaires right here, right now, to assess comfort level, tolerance, task performance, and actions related to the environment. We also did some interviews and focus group to understand the motivation and social dynamics between the groups of people that we were studying. And we are currently analyzing this data to compare it with the standards and evaluate the conditions where occupants were kind of tolerating this discomfort. And this stage provides us with a rich data set that not only revealed how occupants typically respond to discomfort, but also highlights the thresholds that we are looking for. And building on these preliminary findings, the second stage was conducted in the Aachen Workspace Simulation Lab. We had 28 participants in total, and the experiments were designed to assess the impact of temperature change and elapsed time of physiological, perceptual, and behavioral responses, and also how some contextual factors as personality traits, for instance, or sounds, or the level of task engagement could also affect the way people respond to these conditions. So we basically variate the temperatures. We had a ramp where we were having this increase in the temperature, and we were trying to identify the point where the discomfort becomes noticeable, which means when tolerance begins, and then when it may become unbearable. That was if the participants leave the room. I think that never happened. And we had these temperatures from 26 to even 33. That was the final temperature that we had. So now we are checking how this may show us this kind of boundaries of tolerance. We measure a range of responses from the heat rate, the skin temperature, to subjective feelings of discomfort and acceptability. So we are going to use this data as well to check about the boundaries. And finally, the third stage of our research is currently ongoing, and we are using all this information to develop some recommendations for building designs, use, and operation. We are now analyzing this data set to try to understand these behavioral, perceptual, and psychological responses to synthesize these findings into practical guidelines that can kind of help to expand this range of indoor environmental conditions that can somehow help them to enhance occupant comfort and the energy efficiency of buildings. So our research into environmental tolerance not only deepens our understanding of how people interact with their environments, but also challenge current standards for building comfort. By studying discomfort, we are learning, as Sergio mentioned, that experiencing it temporarily can actually improve health and lead to greater long-term satisfaction and well-being. And this is not about advocating for discomfort, but rather acknowledging its occasional benefits and leveraging it to drive improvements in building designs and operation, leading to space that are truly tailored to human needs. So this paradigm shift in the environmental standards for building, moving towards dynamic and adaptive designs that truly prioritize the diverse needs and well-being of occupants, align directly with the approaches that Sergio was mentioning. And I also think about the theme of this talk. So just emphasizing the needs for a more nuanced, occupant-centered approach in the design and management of indoor built environments. So thank you all. I'll let Marshall go.
Thank you, Laura.
Okay, so So we move to the third presentation, which is there. Okay, and you should see it. There we are.
Thank you, Laura. Thank you, Sajo. So following the very informative sessions, I'd like to narrow down the next framework and focus only on indoor occupants. So hello, everyone. My name is Marshall Maskaranj. I am a postdoc at Lab. I work with Sergio and Laura. I'll be presenting about a software tool that can evaluate human factors of occupant comfort, satisfaction, and well-being via simulation. And it can be used to design optimal window openings and identify the best strategy for operation of lighting and shading devices. Among all the IEQ parameters, this part of the talk will be focused on lighting. So we know that light provides us with vision, since human eyes are one of the main senses that we depend upon. But there is more to light than just vision, and literature tells us that light quality, timing, and history are also relevant to the performance of lighting for human factors. Visual perception and visual comfort are instantaneous, and the Nest framework tells us so as well. But factors such as satisfaction and well-being have an extended dimension of time and of other parameters. In this case, the light quality refers to the spectral quality of light, and the dimension of time relates to the light history, as in when it is received. Design of indoor spaces must consider these other aspects as well, and simulation is one of the good ways of doing pre-designed performance evaluation. However, most lighting simulation tools focus on the aspect only of vision. There are some that consider the aspect of spectra as well, and can evaluate the performance of design based on recommendations for spectral light exposure. We are developing OWL, one of the tools that can evaluate aspects beyond vision via simulation. This aspect is called the non-visual aspect. I'd like to give a little bit of background on what is the non-image forming effect of light. Within the human eye, a new category of photoreceptor has recently been found that directly connects to part of the brain that regulates the circadian rhythm. This photoreceptor, called as the intrinsically photosensitive retinal ganglion cell, the IPRGC, thus acts as a time giver when it is triggered. And it tells our body when it thinks morning happens or evening happens. All the body processes therefore get synchronized to this photoreceptor's trigger. But what triggers this photoreceptor? It's actually a certain frequency of light. When we are exposed to any light source of a varying spectral composition, the light that we actually see is regulated by the sensitivity of the vision sensors in the eye, which are mostly the cone cells. But there are also this non-visual sensitivity, which is different from the visual sensitivity. This is the circadian sensitivity. And when we multiply the wavelength with the sensitivity function, and we sum the area under the curve, it provides us the photopic or the melanopic illumination. Now in this diagram, what we are seeing is 4 different types of incident radiations, 4 different spectral quality, and the response of the visual sensors and the activation of the circadian sensors is different, and it is what influences the final outcome. So the ganglion cell therefore gets triggered based on the amount of signature that it receives, and it suppresses the expression of melanopsin. Since melanopsin is the night hormone, its suppression makes us feel alert. For a simulation software to evaluate the visual and non-visual aspect, one very important requirement is to know the spectral quality of the source, which is daylight in. But knowing the spectral quality of daylight is a tough challenge. It varies by the different position of the sky at any point in time. It also varies for the different hours of the day and of the year. Now for the OWL tool, we have used the spectral sky models that were developed at TU Berlin. And these models use the luminance to CCT to SPD conversion approach. And a combination of these models with the radiance engine allows us to evaluate the incident spectra at the observer's eye. So we multiply the spectra that we evaluate at an observer's eye with the photopic and the melanopic sensitivity functions. And therefore we identify the visual and non-visual illumination at any given point in time from any observer's location. So this is what we came up with a first tool called OWL, Occupant Wellbeing Through Lighting. And this is what the dashboard does. So it's a Grasshopper based open source tool where a user can change, for example, the weather file. So you can change the location. Just define the weather file, for example, for Brussels or London or whatever. You can change the geometry and the material at the scene. So you can define what the building looks like, what the material of the building is. You can define where the camera is placed. You can define the time of the analysis period, like which hour of which day of which year, and you can also define the view mask. Now the dependent variables, that means what does this software calculate? It can tell you the sky luminance distribution, which is the luminance distribution of spectra under the sky. It tells you the it tells you the combined SPD of the sky, and it tells you various metrics which are visual and non-visual, both under the sky dome and as well as at the observer's viewing scene. Now this approach can help us evaluate the performance needed for, such as the well building standard criteria, and it can be a pre-designed alternative to required post-occupancy measurement and evaluation. However, a holistic design evaluation needs more than a point-in-time, point-in-space performance. This was a limitation of our first OWL tool, and we therefore set out to address this challenge. Our second tool, called ANU-OWL, is capable of radiance-based evaluation over the grid. It is supported by spectral sky models and has a similar design philosophy. A key points that must be highlighted here are evaluations are simultaneously conducted over the grid for space-centered lighting metrics. And for occupant-centered metrics, the evaluations are conducted for 4 vertical and 1 horizontal orientation for each of the occupied position. So what you're seeing here, it doesn't matter. What you see for each occupied position is the visual and non-visual metrics. And these evaluations are done simultaneously for the entire year. That means for all the 8,760 hours. So
point.
It's
if you need to point, I'll show you how to do it. Yeah, you go there. Perfect. You go to laser pointer, and then you can point.
So for one of the evaluations that you see here are the evaluations over the grid, the flashy stuff. But all those dots you're seeing are the infographic that I'm talking about. And for anyone to comprehend such massive amount of raw data would be crazy. So we developed a novel infographic that processes through the data and tells the designer the performance of the design using graded metrics, the metrics of comfort, satisfaction, energy performance, and user well-being using color codes. So this infographic, since it looks like a UFO, unidentified flying object. In French, it's called as OVNI, which is objet volant non identifié.
Exactly.
Yeah. So we are calling this as the OVNI diagram. So this OVNI is placed at all the occupied positions. Now, here is the connection with the next framework. This is one of the design strategies that can be used. The OVNI diagram includes a consideration of performance for energy use, as well as towards occupant comfort, satisfaction, and well-being. And for that, we have a hemisphere surrounded by rings to present this data. The central hemisphere describes the metric for daylight availability and sufficiency on the horizontal plane for each occupied position. The subsequent rings and its segments describe the non-visual metrics of circadian potential at 4 orientations. So for the 4 orientation, the first ring talks about the circadian potential. The second ring talks about an annual metric for protection from discomfort glare. So you're talking about discomfort or comfort. The final ring will talk about, it's an ongoing work, the satisfaction from window view. So that's talking about satisfaction. So you've got energy in the middle, and then you've got well-being followed by comfort, followed by satisfaction. And this occupant-centered infographic itself describes annual metrics, which I just mentioned. So for space-centered grid-based metrics, ANU-OWL can evaluate daylight autonomy, continuous daylight autonomy, useful daylight illuminance, and average illuminance. Since Climate Studio Ladybug can also do these evaluations, it's not our most important contribution. Where we actually shine is the novel evaluation methodology for calculating metrics for energy use, comfort, and well-being for each occupant. We also have a plan for satisfaction via window view, but that is yet to be operational. So for the energy use via daylight provision, we use the following logic for evaluating performance, and it's graded either as minimum, medium, or high compliance on a horizontal plane. And then we show it as a hemisphere for each of the occupied positions. So the hemisphere in the middle. For non-visual potential, we use Thuong's approximation for evaluating circadian stimulus and use the CS design guideline coupled with proposed annual performance criteria to evaluate it for 4 vertical viewing angles for each of the occupied position. And we display this with the first ring. And again, this is either as a high performance, medium, minimum, or non-compliant. The simplified DGP approach is done for evaluating the protection from discomfort glare, and it's represented via the second ring, again graded as high, medium, minimum, or non-compliant. And here is the result of a parametric study that was done to identify the influence of wall colors on circadian potential and on protection from discomfort glare. So both these parameters are evaluated across 4 orientations. Now in the right is the fraction of occupied positions that receive a high, medium, minimum, or non-compliant performance scores. So we can see that the non-visual potential shifts from a dominant medium for white and yellow walls towards lower performance for blue, green, and red walls. Now for the south orientation, it goes from a dominant minimum to non-compliant for these wall colors. Conversely, for the glare protection, the performance actually increases from white and yellow wall colors to other singular colors. As we can see on the north side, a mixture of performances. A mixture of performances for white switches to a dominant high performance for red, green, and blue colored walls. East and west also follow a similar trend. The south-facing orientation has actually a direct sun, so the reflectance doesn't matter much, and the performance is roughly similar. I'm sorry I had to rush through this a little fast, but it's okay. So annual can also be used to evaluate annual heat maps of performance, both for hourly circadian stimulus and hourly simplified DGP, as instantaneous indicators of circadian stimulus and discomfort glare, which is evident to any occupant for all the annual hours across all 4 orientations. These can obviously be used to create strategies for operating shading elements, such as window blinds with focus on occupant comfort for any hour which has high DGP, and all for turning on the circadian effective lighting to provide the occupant the needed stimulus if any position lacks it, to complement for the lack of well-being or circadian stimulus. So here's finally, this is my last slide. Here's the Grasshopper dashboard for annual tool. Now to discuss the pros and cons of the present state of our development. The utility is high because it can be used for early stage design intervention in facade design. The simulation speed is acceptably high. It's higher than other tools probably. Accuracy is improving because internal reflections are now being considered. The first version of OWL did not have that. It also has one main limitation, that it uses a single channel approach for what is essentially supposed to be a multi-channel evaluation. While this approach makes it faster, the accuracy is lower. But we are working on a multi-channel annual evaluation, and we are calling it as Spectrawl. We are also working on incorporating the view ring, that is the satisfaction for window view quality. So effectively, our annual can be considered a first attempt to incorporate the next model for lighting simulations, where for each occupied position, metrics for well-being, comfort, and satisfaction can be evaluated and demonstrated via the OVNI rings. And the hemisphere at the center presents the energy performance via lighting design. Thank you so much.
Thank you, Marcel. Okay, let's go back to our original seats. There we are. And I'll stop sharing, so we'll see if there is any questions. One thing I wanted to emphasize. So first of all, thank you, Sarah. Thank you for the presentation of Laura and Marshall. We have a bit of disease. We are really eager to do acronyms. So OWL, which was Occupant Well-Being.
I noticed, yeah.
There was also another thing, the OVNI that you explained. So the ring with the sphere in the middle looks like an UFO, and UFO in French is OVNI, so it's objet volant non identifié. But OVNI in our case is occupant visual and non-visual illumination. So it all comes back to acronyms. Sorry about that.
That's fine. Thank you. So yeah, it was very, very interesting, a very rich presentation. So thank you all. I think we already have some questions from the audience. Yeah, I may start with a question. It's for the part that Sergio has presented and Laura also mentioned, because I'm very curious to understand more about what you've mentioned about the temporary drift from comfort zone might be healthy. So can you extend a little bit more on this?
So who are you referring the question to? Is it
both of you, actually, you and Laura, since you already mentioned the same.
I will leave it to Laura to respond first, and then I will complement it. So Laura, I'll switch off my microphone so you can switch on yours.
Okay.
Laura, you're muted.
Can you try? No, just like that. I think you can be heard.
Yeah, can you hear me well there?
Yeah, I can hear you from Sergio's comment.
Okay, that's good. Sorry by that, and I just get a bit lost now about the question. Sorry.
Well, I can.
Again, yeah.
So there has been in the literature, actually not necessarily in the field of building IEQ or building energy, but mostly from the science of endocrinologists or medicine and so forth. Analysis that drifting away from very static and continuous exposure can actually bring important stimuli to the body. And important stimuli to the body are necessary in order to induce endocrinal production. So essentially, a dynamic exposure to environmental condition may be beneficial to stimulate the body to produce the hormones or to have the bodily reactions that are needed to the health of people. If we look at the thermal environment also, I mean, most of us, all of us actually know the research and publications that Richard de Deer has done over the last 10 years about the reconsideration of the construct of allisthesia. Allisthesia was a concept that Kabanak in 1972, I think, had introduced to the building engineering discipline, in which allisthesia from the Greek is aesthesis, so pleasure, of allos, of the new, of something different. Essentially, Kabanak looked at the thermal pleasure, and actually it proposed this model, proposed this vision in which thermal pleasure comes from different experiences. So from moving away from a certain exposure, so from a dynamic environment. And there are reasons to believe that the allisthesia hypothesis may not only be limited to spatial-temporal dynamics in thermal exposure, but also to other factors of indoor environmental quality. I've read a few years a paper that was actually introducing allisthesia to luminous environment, to the way in which we experience visual scenes, and a bit of the work of Marshall is also going into that direction, particularly in a way in which the occupant experience tries to reconcile visual, non-visual, and so in essential we can say, simplifying a bit, physical and physiological, but also psychological interpretations, like for example view quality. Guys, do you want to add anything with respect to temporal drifts or tolerance and so forth? Thermal or visual, whatever you want.
Yeah, no, maybe just what you were saying about all the medical studies that have been conducted. They're also kind of connected on this new concept of de-habituation. So what we are used to being exposed to, and our body just adapt to it. And when we go beyond that, then we allow to our body to basically use more energy and use these reserves of energy on a metabolic level. It can be do what it's supposed to do, rather than we just staying indoors, quiet, and not using that energy. So I think that's one of the most interesting sides of going this, like just trying to change the conditions that we are usually exposed to.
And also, I very often refer to something very banal. I mean, it's not scientific at all, but our body needs to go through states of discomfort in order to reach comfort. We need to feel sleepy in order to find the stimulus to go to bed. We need to feel hungry in order to go and hunt for food. So in a way, we need to go through the state of slight discomfort in order to then provide for the needs of our body. So in a way, those somehow cyclic vision of the way in which we can satisfy our needs, on which our body actually tells us in a way we have a need, is something that maybe we should try also to consider in the way in which we configure our built environments.
Okay, very well. So I think, yeah, thermal pleasure, it's a new keyword for me.
Yeah,
So
absolutely.
Yeah. Okay, so I think I will pull have some questions from the chat. So I have here Ahmad Taki. Hi, Ahmad, and he has a few questions for you guys. So the first question,
I see it on the chat, the one on preference and expectations, knowledge, satisfaction, and comfort. So cultural and social issues were mentioned, and this is obviously important. I mean, expectations in the model that we have proposed, experience and expectations. So in a way, experience tells about the past, expectation tells about the future, are very much embedded into interpretation of satisfaction. And the reason why I'm saying that is that very often in our surveys, for example, we ask how satisfied are you with the thermal environment? But then obviously the background of people, the social and cultural constructs that have built that person in a way can influence the way in which the person responds. There has been significant research in terms of seeing whether cultural and social backgrounds may influence the way in which we perceive our environment. I mean, for example, I can mention amongst many others, Clotilde Pilson did a PhD on the socio-environmental influences to glare perception. So to see whether the way in which we experience and expect, in a way, to respond to glare situations may differ depending on the social-cultural environment from where people have come. From a thermal perspective, social-cultural background also very often implies social habits in terms, for example, thinking at the way in which we dress at work. So, for example, the formal attires that are in a business environment very much required, I may say, in Eastern culture, compared to a much more relaxed environment in the business world, in the Western side of our world. So obviously all of this has an influence, and it's actually important that we consider and we embed that into our design rules and also in our design criteria. So definitely yes. We also talk about corrections to existing comfort models. I think that they are necessary. We are still not at the point of having maybe, I mean, the robust evidence from research that can really tell us how to introduce correcting factors or whatever into our comfort models. But maybe on the other hand, the thing that we can more easily do is to allow our models to drift and to variate a bit more. I always say that standards are standards, so they look at standard conditions for a standard person, but we know that buildings fluctuate, people behave dynamically and react dynamically to exposure. So there's nothing static or standard about neither buildings or people. But standards are based very often on means. So we look at large populations, we look at central tendencies, and that's where we put the target of our standards. I advocate for reinforcing the value of variance with respect to the value of the mean. So we should, yes, probably regulator standards based on the mean value that we can find into coming from research, but then on the other end allow a little bit more variance due to intra and inter-individual differences that may be in discrepancies between people perception, as the question implies.
Yeah, thank you. Well, yeah, I can completely agree with you, Sergio, especially for the first part when talking about the cultural differences. Because I came across like this experience where we did this study, me and Michael, and it was mainly about the cultural differences, but from perspective of visual privacy. And it was interesting to see how people may prioritize their other needs for daylight or for ventilation and related to the shading control. So I think that would be a very important topics when it comes to either visual or thermal perception of people from different cultures.
Indeed.
So the other question is for Laura. So Ahmed asks if you did measure the tolerance boundary in a reverse way, so the transition from an environment with a PV model to a state where people start feeling cool or discomfort.
Yeah.
Okay. Short answer, not yet.
Not yet. So
not yet. Okay.
I have a very lucky condition of being in Belgium. So, well, there's two things. First of all, that obviously the main need of our building from an energy perspective is from the heating. So it's more likely that people will feel cold and that will have need for energy-assisted mechanical systems that provide heating. I think that on the other side, I'm not expecting symmetrical boundaries of tolerance. I think that we react to heat in a different way than we react to cold. But yeah, this is something that probably we need to do. Very likely, we also may welcome collaboration with countries or scholars that come from warmer climates in order to also better take into account cultural and social expectations as the question of before, and hence the reason why I'm not expecting symmetry in terms of outcomes. So more work to come.
Exactly. Makes sense.
Okay. So I think we also have a question for Marshall. Marshall, I think you already responded to this question, but yeah, if you can share the question and the answer with the audience as well. So Ahmed asked you about the tool that you developed, right? Let me check the question again. Yeah,
so there was a question about whether the
when we achieved through artificial
or just natural lighting or both in your modeling. Well, that's an interesting question. So artificial or electric lighting is not necessarily better than natural lighting in providing the specific spectral characteristics of light that are to whom the intrinsically photosensitive retinal ganglion cells are sensitive. So from a physical perspective, electric light can reproduce the same conditions of natural light. Natural light, however, has the further advantage of coming with a continuous spectrum, has the further advantage of continually dynamically changing throughout the day, has the advantage of coming with further benefits, like, for example, a view to the outside. So in a way, the entrainment of the circadian stimulus not only comes from the excitement of the EPRGCs, but also comes from different avenues, from different cues that may be psychological, that may be mental states, and so forth. So obviously, from that perspective, natural light offers us plenty of more opportunities to enhance for the well-being, whereas the well-being is considered as a multi-dimensional construct. So not only health may be more related to the entrainment of the circadian system, well-being is more a state of flourishing. So from that perspective, I think that the benefits of natural light are much wider than those that can be provided by light produced by artificial or electric means.
Yeah, okay. All right, so I think I have also a question for Marshall about the tool that you shared with us, because you mentioned that you did some analysis for discomfort glare using DGP.
Sorry, I did not get that.
Say it again, Saha.
I could not hear that.
So I'm saying regarding to the tool, so you did some analysis for glare perception using DGP, right? And so the first question is why DGP in particular? The other question would be considering also the extreme values, for example, for the CCT, if we have like artificial lighting, LED lighting, or filtered daylight through colored glazing, for example. Have you looked at this from any perspective when developing your tool?
So this tool is actually based on existing standards. We are doing a user testing experiment to also understand the mixed effect of color temperature and time of day on discomfort glare. But over here, we've used existing standards. And your question was, why did we use DGP? We didn't actually use DGP. We used simplified DGP, which is based on vertical illuminance. So essentially, radiance evaluates the illuminance falling on a vertical plane. And then that could be converted to any other formula that you could translate it to. So simplified DGP is one of those that even Climate Studio uses. And that's why we use simplified DGP for that certain vertical ring. But, and when you asked about whether we also talk about colored glazing, so colored glazing can in principle be used for the new tool that we are talking about, because it's an entirely multi-channel spectral simulations.
Yeah.
The one that we are building upon. This one does a reduced version of it, a faster version of it. There are assumptions over there, but then as I said, the speed is much faster, accuracy is not as high. So it's good for pre-designed simulations, but not really good for detailed simulations.
All right. Thank you, Marshall. We have more questions in the chat if the time allows. So we have about 8 minutes. So I have this question from Ala. She asks, is the new comfort model affect the energy consumption in the building or put into consideration? I think this question for Laura's part, if I'm not mistaken.
Well, I think that all of us could respond to that. And one of the things probably is what are the energy consequences of the next model? So what are the energy consequences of trying to define a difference between comfort, satisfaction, health, and well-being? I think that one of the things that we have to consider first and foremost is why we design buildings and what are buildings for. So buildings are there for responding to human needs, and human needs are not univocally addressed by 20 degrees, 50% relative humidity, and 500 lux on the working plane. So I think that one thing that you have to consider is, first of all, what is the building for? Who are you providing conditions for, at what time and in what conditions? So buildings design needs to be driven by priorities. If, for example, you're designing a ward for elderly people that are confined in bed, obviously visual comfort may not be the priority in there, but you would want to try to have conditions that allow, for example, to support their circadian cycles, their sleep quality as much as possible. On the other hand, if you are providing for an office building, which is very likely to be half empty for most of the time, due, for example, to hybrid working conditions, you may and should be able to substantially negotiate on the standards of comfort that you apply for. For example, by lowering down the general temperature or ambient lighting, and then allowing, on the other hand, use of personal comfort systems so that energy may effectively be used only and where it is necessary. So if the question is this new comfort model affecting the energy consumption? I would say I hope so. But I hope so by a more careful and capillary understanding of what people need and where and when, and what are the conditions that we need to provide for them, depending on their specific characteristics at specific times and at specific season. we haven't mentioned season, we haven't mentioned time of day, but for example, when we talk about individual variabilities, we also have to consider that people needs and preference themselves may differ substantially depending on when we measure them.
Okay, great. Thank you. Thank you, Sergio. So I think Lena has a question. Lena, if you want to come in and ask the question, I think your mic is on.
I think that Lena had asked these questions that I glanced through about the healthcare facilities, and the reason why I also wanted to address that in my response to the previous question.
Yeah, I think it's because Lena. Well, I mean, in this case,
there's another
I
aspect that Lena says. Lena mentions in a question is that. In healthcare facilities. So the question that Lina has, it's in the chat if you want to look at it, is healthcare facilities are very, very delicate environment because you have so many conflicting requirements. Patient is one thing, but then it depends on the patient, because if the patient is confined in bed for the full day, obviously you have to provide directly the full dynamic that people need in order to guarantee the circadian rhythm. Well, on the other hand, if patients are somehow mobile, you can actually assume that by the dynamic changes of environment, they may have that level of exposure. On the other hand, we said that in healthcare facility, comfort is not necessarily the priority, but that may not be the same thing in an emergency room. In an emergency room, you should not obviously look at circadian rhythm, but really visual comfort is what matters, because people have to take decision immediately, have to be able to to read and to assess the state of a patient in a matter of seconds in order to save lives. Hence the reason why we have to really look at what is really the priority, what is that we are designing for, and based on that, actually try to define, address that with our building design strategies. There was an interesting question. I can't find it anymore. Whether comfort was a bad word.
Yeah.
Well, I respond in a very strategic way. It's a comfortable word. So we tend to be very much comfortable in using the word comfort.
Enough. All right. So I got this comment from Sue, and she says it might be interesting to compare the well-being outcomes between optimized indoor environment and biophilic environments. Would you like to comment on this?
Yes. Yes. It's not an easy question because I mean we have a number of scientific studies that have studied, in a way, have compared man-made versus nature responses, or responses to environments that are man-made with respect to nature. And people tend to obviously respond that they prefer being surrounded by nature, and that enhances their well-being. But on the other hand, it depends on how you're measuring the well-being. So if you're measuring the well-being by responses of people, conscious responses of people, you're very likely to find that people prefer to be surrounded by nature. I think it's something that is evolutionary. We come from nature, and we tend to get back to that. On the other hand, we have done some experiments in the past, and I refer here to the view quality experiments, view preference experiments performed by Aisha Batul at the University of Nottingham, where we compared not only the preference expressed by people. Okay, hello. Yeah, Aisha, hi. Where we compared not only the preference expressed by people, but the gaze behavior with respect to urban environment compared to nature. And we could see that differences in gaze behavior were quite substantial, particularly whereas in an urban environment, and Aisha, please correct me if I'm wrong, in an urban environment, the people tend to look at things in a more exploratory way, so tend to have much more eye movements for shorter periods of time. Why could that have an implication on well-being? It could have an implication because obviously by having rapid movements through different visual scenes and scenes that have different spectral characteristics of light, but also different luminances, you may be exposed to a wider range of stimuli that may effectively have circadian effects with respect, on the other hand, to a calm natural environment in which your fixations are much longer. So although people may prefer from the personal judgment to be submerged by nature, or to have, for example, a view to the outside that is made by natural elements, from a physiological response to an external environment, it may be more beneficial to be able to experience the variety and the dynamism of a open environment. And I see Aisha all of a sudden appearing on the screen. And he's probably going to say, no, you got it wrong. After 4 years of my PhD, I haven't got a thing.
No, that's right.
Thank you, good to see you.
Good to see you all. Thank you.
Good to see you, Aisha. So yeah, I think it will be fantastic for Aisha to come and comment also about this.
But it's good. I feel among family. It's so nice.
Aisha, do you have anything to add regarding the last comment from Sergio?
No, not at all. Actually, no. I think you wrapped it up pretty well. And it also reminds me that he's probably connected to my PhD more than I am.
And one of the things that we said with Aisha is that very often people do not really know what they prefer. So, and I remember in one of the early discussions that we had in your PhD, if you ask a sample of people, what is your favorite ice cream flavor, everybody will say chocolate. But then once you're exposed to a number of flavors, very few will actually take the chocolate. So it's like sort of a preconception that everybody says, it's nature, it's a view to the outside, it's the ocean and whatever. But on the other end, they would behave completely different in the real world.
Yeah.
Thank you, Sergio. Thank you all for this interesting presentation. I think this concludes today's presentation, just on time, a little bit. Yeah, a couple of minutes late, but that's all right.
Yeah, you knew that.
Really enjoyed. Yeah, I mean, it was a fantastic presentation, and it touched many aspects actually of human-centric design. So thank you very much. For the audience who asked about the recordings, I'm gonna share it with you on LinkedIn, on the event page, and also via email. So for who registered using the Google form. So thank you again, and see you in our next talk on the 2nd of May. Thank you.
Thank you to Sar. Thank you, guys, and thank you all. Thank you, Laura.
Thank you.
Marshall. Thank you. Bye.
Bye.